Okay. Day 6, tuning treble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Starfruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. He convinced the other elves, all right, as if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix a communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. So it looks like the smallest number we'll be able to report is 4. For example, suppose you receive the following data stream buffer. After the first 3 characters have been received, MJQ, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character, making the most recent 4 characters MJQJ. But because J is repeated, this isn't a marker. First time a marker appears is after the 7th character arrives. 1, 2, 3, 4, 5, 6, 7. So J, P, Q, M. Once it does, the last 4 characters received are J, P, Q, M, which are all different. In this case, your subroutine should report the value 7. Because the first start of packet marker is complete after 7 characters have been processed. Here are a few more examples. How many characters need to be processed before the first start of packet marker is detected? All right, seems super easy. So what we're going to be doing here is, let's grab this first. Oh, that's huge. Very nice. So what we're going to be doing here is using what's called a sliding window iterator. Sliding window iterator, where we'll iterate over sub-slices of this vector, this array of characters. And the window size we'll be using is 4. So if we have this sort of string, then we'll split that string into a vector of characters, and then we'll start the sliding window. Let's just do this real fast. Whoops. And our window is going to look like 1, 2, 3, 4. And we'll process just this substring, or this vector slice. And then we can take the next one. And we just kind of step through one slice at a time until we get to a slice where all the characters are different. So the first thing we're going to have to set up is sliding window frame, which I think should just be a simple function. I think that's already built into Rust. The second thing we have to set up is character check. Are all entries of vector slice unique? And there might be a fast way to do that too. But I don't know yet what that's going to look like. So let's define lines, 2 lines. Actually, we don't even need to do 2 lines because there's only 1 line in our input. So use standard file system file. No, just file system. And we'll let input equal file system read to string. Use path buff from inputs / input 6.input.text .unwrap .unwrap. We can make that smaller. Okay, so here we just pull in our input, and just to make sure that's working, we can print line input and cargo run bin day 6. Oh. Standard path. All right, nice and easy. So that is fine. That's a little big. So it took a little while to compile that. Let's see if it has the same issue this time. No, that's no problem. All right, print line this. All right, we don't need that. So now we can get into the weeds of it. So first we're going to define this sliding window frame. And we can just do a simple function call. So let frames or windows equal input.chars, which returns an iterator. And then we can do .window. No, we collect .collect as a vector of chars. Let chars equal that. And then we can let windows equal chars dot windows. Look at that. How did it know? And the size is 4. So this is going to be a window of size 4. And to test if that works, let's print line this guy, windows.next. So we'll see what the first 4 characters are. This needs to be mutable. Windows.next option, okay. Reference to a char. Let's just do that a few times and see if that's working all right as we expect it. TZLT, ZLTZ, LTZL. Let's go up to the top. TLZT, LZ, ZLT. Yeah, okay, that's working all right. So this is done. Nice and easy. And we're actually going to be looping over this, so we don't have to assign this to a variable. We can just, for window in press that window.4, we'll do some action. So this is going to be a slice, a vector slice or list slice. Yeah, so let's see how we can manipulate this. Now, here's what I don't know what we're going to do yet. Function unique, all unique. And it's going to take in a slice of characters. And return a Boolean. Missing type for functional parameter. Oh, we need the name. Slice. And we're going to, we can return true or false. Let's just return false for now. So how do we do this check? So I think what we're going to do is pop off the end of, okay, because we have something like this. A, B, C, D. That. All right, so those are just two example inputs. So I think what we can do is pop off the end and check to see if the remaining, if what remains contains what popped off. So it's going to look something like this. We need to make this a mutable reference or something that's owned. Owned might be better. Characters, and it's actually going to be 4. We know it's going to be 4. So, slice dot pop let char equals slice dot pop. Oh, this is interesting. You can't push and pop on a list, on an array. What functions do we have? Just finding stuff. Contains, copy from slice. That's interesting. Window.to owned. What does this return? Vector. Oh, that's so much nicer. That's so much nicer. All right, we're going to work with a vector of characters. Vector of characters. So that will let us mutate, pop, do stuff like that. So now we can do let character equal slice.pop .unwrap. This is going to be mutable vector. Why can't we mutate? Cannot borrow slice as mutable, as it is not declared as mutable. Vec mute char? What's going on? You can't just take in a... I don't want to borrow. I want to own. At mutate. Weird. That was weird. There's something I don't understand about that. So we're going to pop off the last thing, unwrap, and return what's left, slice dot contains C. And that is a Boolean at C. Now this is going to do it only for the for one thing. So what's happening is let's see. So this, let's just take this example here. It pops off and it assigns C to this A right here, and assigns slice to a new vector containing A, B, C. So that last A popped off. This is confusing. Yeah, anyway, these are all in quotes. And then it asks, does the slice contain the character A? And it does, so it will return true. Now this is only going to do it once, and we have to do it 4 times. So we can do a little while loop. While let C sum C equals slice.pop. If slice.contains C, return true, and that's an early return. Else return false. So this is the same deal. We pop off the last thing, and if it returns a sum value, we do this pop. It gives us an option. If the option returns some character, then we know that the list wasn't empty. And so then we can do this check to see if what's left of the slice contains what we just popped off, meaning that it was in there twice. And if it does, then we can return true. Otherwise, if we get through the whole thing, we get through all 4 characters, there's no overlap, we'll return false. And actually, we're asking if it's all unique, and so we should return false if it's not all unique, true if it is. And that should be just, that's our business logic right there. So let's write a test for that. Test function all test all unique. We'll let our slice equal this vector of A, B, C, D. We'll let, so this is unique slice. Unique slice. And this should give us true when we run the function. And we'll let a repeated slice, so slice with repeated characters, equal vector of A, B, C, D. I'm sorry, A. And we should assert that unique slice, what's our function name? All unique of unique slice, which, I mean, yeah, we can do that. Have mute unique slice equals, are these all unique? Yes. We do have to declare these as mutable. And we can assert equals all unique of repeated slice. There's a repeat here, so that should be false. And let's give it a go. Cargo test day 6. Let's just allow unused variables. We don't need those. That's all unique, and that worked. Now, it's not very robust, like I don't have all the edge cases, but that's okay. All right, so now let's define a new function where we just scroll through and test that for all strings. So it's gonna be called process string, or start of packet. Let's call it start of packet. Start of packet. It's gonna take a string, signal string, and it's gonna return the index where, or the number of characters processed before we hit this all unique value. Cool. So what this is going to look like is we'll take our string and turn it into a bunch of characters. Just return 0. Now just give it a signal. Then we'll scroll through like our windows and feed our windows into this function. If all unique window, and we'll need to make this mutable. We'll need to make this, no we don't, because we're just gonna to mute owned. How do we do this? To owned let slice equal window dot to owned. Hope that'll work. Usually by cloning. All right, so I think that should be cloned. We shouldn't have any issues there. And then we can run this all unique test on @mutSlice. And if this is true, then we'll return something. Otherwise, we'll go back to the next window. So what should we return? We'll let number of characters, or signal length, equal, now we're starting at character 4. So our first window is already 4 characters in. So we'll let that equal 4. And if it's all unique, we'll just return number of characters. Otherwise, use size. Otherwise, why is this freaking out? It's an early return. otherwise this, and we can also return, let's just return some result, just in case we get to the end of the buffer, we don't find any results. We can signal that. So we'll return some number of characters. So we open up the slice. If they're all unique, then we'll return that number of characters. Otherwise, we'll increment the number of characters and continue. All right, let's write in our tests. Test function. End to end. So we have this input. Let test string 1 equals string from this. And we'll just make a couple of these. 3, 4. I guess really what we're testing is start of packet. And we'll run this test. So cert equals start of packet. It's 1 is equal to, the answer should be 5. Two, 3, 4, and the rest 6, 10, 11. 6, 10, 11, and this is all sum. Wrap that. All right, let's give that a go. Cargo test. That worked. Nice. Man, Rust is nice. We love Rust. Print line. Signal start at variable. Variable is start of packet input. Unwrap. Because we assume there's going to be an answer. Yeah. Cargo run. Day 6. Let's see what we got. Signal starts here. Let's see if that's right. Like that. That's right. Continue to part 2. Your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A start of message marker is just like the start of packet marker, except it consists of 14 distinct characters rather than 4. How many characters need to be processed before the first start of message detected? Trivial. Trivial. Start of packet, start of message. It's a lot like DNA, and our window is just size 14, right? And, or what is that? Yeah. 14. We start at 14. Let's input. Does this take ownership of input? Signal, yeah, because it'll break input down, so we'll have to copy input or read it again. And let's just read it again. message start here. There. Message starts there. Now, there are plenty of optimizations we can do. Running both of these checks at the same time. Maybe, I don't know. But this is good. Let's see if it's even right. That's right. Okay, cool. Well, there we go. So just as a quick review, the biggest thing we saw was this very convenient Windows function, which pulls out a Windows iterator, which is a slice of whatever iterator we put in or whatever vector. We also saw the part of the all unique thing, which was popping off the last character and seeing if what remains contained what we just popped off, which would mean that character was doubled up. So, great.